Hey everybody, is this working? Cool. Did everybody enjoy the after party last night? I think the people who enjoyed it the most are not here to answer that question. But awesome. Cool, so you might have seen on the schedule this talk was called Selections. That's just Taylor being a jackass. The talk is actually called Curing the Common Loop. So yeah, let's get into it. So how many of you have ever written code or seen code or worked on code that looks like this kind of general shape and vibe? Everybody? Right? So today we're going to talk about how to never, ever, ever write code that looks like that ever again. So to do that, we got to go over some sort of fundamentals first. So I want to talk to you a little bit about higher order functions. So a higher order function is a function that either takes a function as a parameter, returns a function, or does both. And we're at Laracon here. We all have assumably worked with Laravel applications before. You see a lot of high order functions all the time working with Laravel. For example, defining a route. This route get function, that's a higher order function because it takes a closure as a parameter, right? Or sending mail. Until Laravel 5.3 anyways, you can pass this closure at the end that lets you specify all the stuff about the actual message that you want to send. So that makes mail send a higher order function. Or a database transaction, where you just want to run some code inside of a database transaction. You can pass a closure to the transaction method. And that transaction method is a higher order function because it takes a function as a parameter. So higher order functions are important because they afford more powerful abstractions. And I'm going to talk about what this means. But for me, higher order functions are something I've used for a long time, right? Especially in JavaScript, there's closures everywhere all the time. And you use them in other people's APIs a lot, and you just kind of think that you understand what they are and how they work and what the benefits of them are and stuff. But it wasn't until sometime in the last few years for me that I really started to realize what makes it a powerful concept and why I don't think I could ever program in a language that doesn't have them again. So for example, here's a little bit of code where we're trying to get the email address from a bunch of customers, right? So we start with an empty array of customer emails. We loop over the customers. We pull out that customer's email and stick it in the array, and then eventually we return those customers' emails. This is a pattern that you've probably seen in a lot of code bases all the time, all over the place. Here's a similar piece of code where we're trying to figure out some stock totals, maybe in our store. So we have this inventory items, and an inventory item is a product that we have along with how many of it we have on hand and what we're selling it for. And maybe we're trying to generate a report that lets us know what is the value of that we have on hand of each product. So here we're looping over the inventory items and putting together this stock total data structure that kind of tells us, okay, well, this is what the product is by getting the product's name, and the total value we have on hand is the quantity we have of that item multiplied by the price of that item, and then we return that, and maybe we use that for some sort of report or something. So looking at these two pieces of code, the only thing that's really different is what we're actually sticking in that array that we're building, right? Here we're extracting a customer's email, and in this example, we're building this stock total data structure. If we look at all the other code, except for that kind of array there, and generalize the names, we end up with something like this, where there's a results array, and we're iterating over items, and creating a result, and sticking it in our results, and returning our results. If we look at the other piece of code, and we replace that kind of grayed out piece with what we were doing there, now the only difference between these two pieces of code is just what the result is, just what's getting put into that results kind of array. So this is a common thing that you might see in a bunch of different places in your applications. I know it's something that I had repeated many, many times until I figured out how to kind of create abstractions around it. But it's something that we can generalize. But how can we generalize it? Because normally, when you have some duplicated code in two pieces of code, you can extract that duplicated code to a function and just call it in both places and you're all right. Here, it's not duplicated code that we want to extract. It's code that's different that we want to extract. Everything is the same about these two pieces of code except for one small thing. And it's not just a simple value. So anonymous functions are really good at extracting code that's different. So if we extract that little bit of code there where we're getting the email from the customer and move that up into a callback that takes the item, and then run that callback in that loop, and then do the exact same thing with our stock totals example. Now in each example, we have two pieces of code that's exactly the same. All that's different is what the callback is. And now that we have two pieces of code that are exactly the same, we can pull that out and stick it in a function, and we've implemented array map from first principles, essentially. Kind of a simplified version of array map. So looking at our original examples now, this customer emails result that we're trying to build, instead of having to do all this loop stuff, we can just call array map, pass in the transformation that we want to perform and the list that we're trying to transform, and now we'll get those emails back. And we can do the same thing with the stock totals. We can replace all that kind of repetitive looping code with just a call to array map that tells us what we're trying to map these inventory items into. So another example. Here's another pattern that you probably see a lot. We're trying to figure out like which products in our store are out of stock. So we start with an empty list of out-of-stock products. We loop over the products. We check if the product is out of stock, add it to the list of out-of-stock products. If not, do nothing, and then return the out-of-stock products at the end of the day. Here's a similar one where maybe we're trying to build a list of expensive products. So if the product is more than $100, then we'll stick it into our result array that we're building. Otherwise, we won't. So again, if we generalize the names, in both cases, the only thing that's really different is this conditional, right? In one, we're checking if the product is out of stock, and one, we're checking if the item's price is greater than 100. So, using the same sort of approach, we can extract that into a callback, do that in both cases, and now again, we have two pieces of code that are exactly the same. Right? The only thing that's different is what we did in the callback. And if we pull that out into a function, we've implemented array filter from first principles. So we can take this code where we're trying to get these out-of-stock products and replace that with just a call to array filter. So the loop and the conditional both disappear. Same with the expensive products. It's just a call to array filter where we just pass the expression that we want to use to filter against. So what about this example? This is a little bit more complicated, right? We're trying to get the email addresses of all the employees in the sales department. So we start with a list of employees. We put together an empty array that we're going to call emails, where we're going to stick these kind of emails that we're fetching off of these employees. We loop over the employees. We check to see if the employee's department is sales, then we want to get that employee's email and stick it in the emails array. So if you look at like just this bit of code here, kind of looks like map, right? Like we're looping over the employees, we're like performing a transformation, which is extracting their email and sticking it in the emails. But because of this like conditional here, we can't use map, because we only want to get the email addresses of the employees in the sales department. And if we just like used a map here, it would give us the email addresses of every employee, right? So often when I find myself in this situation, kind of thinking about like, okay, well, you know, I can't use map here because it would apply to every employee, not just the employees in the sales department. I try and kind of reframe that in like a more positive way and try and figure out like, what can I do that could allow me to use map? So instead of thinking, you know, I can't use map because it would be applied to every employee and I only want to apply it to the employees in the sales department, I can say, well, I could use map if I was only working with employees that were in the sales department. So looking at this code again, if we figure out how to get the employees that are just in the sales department, which we can do with array filter, right? We're going to take our original list of employees, pass it to array filter, and have it only return the employees in the sales department. Now we have a list of employees that are just the sales employees. We can go down to this code at the bottom here. We can replace this employees variable with our sales employees. And now this conditional is totally unnecessary because we know that we're working with sales employees. We don't have to verify that they're in the sales department. So that conditional goes away. And now what we're left with at the bottom here, hey, that actually is map now. So if we take this chunk of code, we can replace that with a call to array map, and now we're left with this function. So we filter out any employees that aren't in the sales department. We map those employees into their email addresses and return those email addresses. And now we have no loops or conditionals in our code, which is kind of cool. So I want to take a minute to talk about some things that I hate. Number one is for loops, which you might have gathered at this point, right? Number two is conditionals. And so far, our code is not hateable because it has no for loops and it has no conditionals, right? But number three is temporary variables. The fundamentals of programming, all bad things. So if we look at this code, we have not one, but two evil, horrible temporary variables. So how do you get rid of temporary variables in code? One way that you can do it is to use a refactoring called inline temp, where you basically find places where you're using that temporary variable and just stick whatever the value of that temporary variable is in line where you're using that temporary variable. And it's particularly useful in cases like this, where you're creating these temporary variables, but each one is only getting used once. It's a different situation if you're creating a temporary variable and using it multiple times. Inlining it would create duplication, right? But if you're just using it once, inline temp can be a really good solution. So what would it look like to do that? So where are we using that emails variable? Well, the only place we're using it is here where we're returning it. Like we're assigning it above, but we're only using it here. So if we inline that, we just end up returning the array map call directly, which is fine. I'm OK with that. But now looking at the next temporary variable, which is the sales employees variable, and that's the only place we're using it here. If we try and inline that with the value, which is basically this array filter call, we end up with this. And this isn't great, in my opinion. When you look at this, it's kind of hard to grok exactly what's going on. Like, you see map first, but filter is actually being applied first. And when this starts to grow and become more than just two calls, it can get really complicated and difficult to understand. So this is kind of a problem with primitives in general. And I want to show you another example using strings. So here we have a function that's taking a snake case string, like hello there, Laracon at the top, and converting it to a camel case string. And when you look at this function, it takes a little bit of effort to kind of figure out exactly what's happening, right? You've got like 4 operations happening, but the first one that's actually being called is string replace, and then uppercase words, and then string replace again, and then lowercase first. It's sort of like totally inside out, right? You have to like follow the parentheses and kind of find the innermost call, and then read backwards from there, and kind of read both sides as you go and try and keep it all in your head and figure out how it's working. And that's because with primitive values like strings, we have to operate on them from the outside. So we have to write functions that take that primitive as a parameter, as well as any other parameters related to the operation that we're trying to perform. Now compare that to this hypothetical situation where strings in PHP were objects, and strings could have methods on them. So instead of having like stir replace down on like line 4 there in the middle, getting past to uppercase words, getting past to string replace, getting past to lowercase first, instead we just take the string, we replace the underscores with spaces, we uppercase the words, we replace the spaces with an empty string, and then we lowercase the first word, or the first letter, sorry. And that gives us our camel case string. And to me, this is a lot easier to read, and a lot easier to understand. Now, we can do that same sort of thing with arrays in PHP using collections. And Laravel has collections all over the place out of the box. Like anytime you return something from the database, it comes back as a collection. All your Eloquent stuff is collections. So this is what it would look like to use collections instead of operating on the arrays as primitives. If we look at this array filter call here, instead of using the array filter function and passing in employees, we can say that employees is now a collection object which has a filter method. We call filter on the employees, and that gives us our sales employees. Similarly, down below, instead of using the array map function and operating on the sales employees array, we have a sales employees collection. And we call the map function on the sales employees collection, and that gives us our emails. Now if we inline our temporary variables, we end up with something like this, which is what's referred to as a collection pipeline, where we're taking some data, piping it through one transformation, in this case filter, which now these things are actually appearing in the actual order that they're actually being executed in, which makes it a lot easier to understand. So you're piping the employees through filter, and then what comes out of filter is the sales employees, and we pipe that into map, and then we just return the email of that employee, and now we have the email addresses of the sales employees. So this is kind of like a simple example, but it's a useful way to kind of show how we can like eliminate all loops, conditionals, and temporary variables in our code using this sort of functional programming style, and especially when you take advantage of collections in PHP that let us kind of do things in this kind of left to right, first to last way versus this kind of confusing inside-out approach. So let's write some code, because slides are stupid. All right, get set up here. So here's that, sorry, I lost my voice a little bit on the first day, so I'm trying to make it through here, but I might squeak and crack a little bit here and there. Here's that piece of code that we were actually looking at originally. This, sorry? Bigger? Okay. Is that better? We'll have to scroll through it, which kind of makes the point even better, to be honest. So I just put together a little Laravel app because it makes it kind of easy to demo these in the browser. So we've got this grim route here, because this code is looking pretty grim. So we start with some employees, and let's talk about what this code is actually trying to do. So this code is trying to figure out what the total revenue is that our company brings in from our best customers. And our best customers are defined as any customer who has paid us at least $75,000. So we want to loop over all the employees, figure out what district that employee is in. So we're trying to figure out how much money do we earn from our best customers in the Louisville district. So we get the district of that employee. So if the employee's district is Louisville, then we want to get that employee's customers. We loop over all the customers that that employee serves. We initialize this customer total sales variable to 0. We loop over all the orders that that customer has placed. We add the value of that order to our customer total sales variable. If the total sales that that customer has been involved in is greater than or equal to our minimum sales, which is $75,000 up here, then we include their sales in our total revenue and then ultimately return that. And I'm formatting it a bit here so we can kind of see it nicely in the browser. So this is the value that we're getting right now based on a bunch of seed data that I threw into the application. And we're going to kind of use this as a reference point to make sure we're not goofing anything up as we try and refactor this to use a collection pipeline style. So scrolling down, I've got another route here called Zonda. And we're going to just kind of walk through this code and try and refactor it to remove all loops, conditionals, and temporary variables using collection pipeline programming. So based on kind of the stuff that we learned earlier about like map and filter, I'm looking through this code and I'm trying to look for opportunities to try and basically unindent code as much as possible, right? So the first thing that kind of sticks out to me is this conditional, right? We've got all this important code is kind of all the way down and nested deep here, and we're only ever executing this code if the employee is in the Louisville district. So we could get rid of this conditional if we knew in advance that we only had employees in the Louisville district, right? And that's what a filter is for. So let's filter out any employees that are in a different district so we can try and get rid of this conditional. So let's create a variable for now called Louisville employees. I always put the S before the I don't know. Louisville employees equals. So we're going to take our employees collection and we're going to filter it. It's going to take an employee, and we want to return whatever the expression is that determines if this is an employee that we want to keep. And we want to keep any employees that are in the Louisville district. So we can return employee district equals Louisville. So now let's head to the browser quickly just to make sure we're not screwing anything up. Everything is still good because we haven't actually used that code yet. Let's just delete this conditional completely. Unindent this code. And instead of looping over just the employees, now we'll loop over the Louisville employees. Run this again, and we're still getting this $1.9 million value. So we're making a little bit of progress. So let's see, what is the next thing that we want to be able to do? Well, the reason that we're looping over all of the employees is to be able to loop over all of their customers, to figure out the total sales of each customer, right? So it sounds like maybe we could eliminate one of these loops if we just had all of the customers instead of having to work with employees and then nested under that get the customers from that employee. So what could we do to make it so that we were working with just every customer in the system to begin with? So let's think about it. And we're going to introduce a bunch of new operations and stuff as we go here, and I'll take a little bit of time to explain how they work. But if we wanted to get all customers, what would it look like? So we have the Louisville employees. It sounds like we could use a map operation, right? We have the employees. We're trying to get the customers from those employees. If we can take each employee and kind of transform each employee into a list of its customers, then in theory, that should give us all the customers in the system. So if we say all customers is equal to Louisville employees, map function, which takes the employee, and then we return what we want to put into this new collection that we're building. So if we return employee customers, let's just die and dump that here just to kind of show you what we get. If we head back to the browser, so we're getting a collection of 6 items, which is a little bit suspicious to me. And if we open it, each item, rather than being a customer, is a collection of customers. So when we took the employees and we mapped those employees into their customers, it didn't give us just one big list of customers. It gave us a list of each employee's customers, if that makes sense. So we had 6 employees in our original collection, and now we've mapped that into 6 groups of customers, which is the customers that belong to each employee. So how can we turn this into just one big list of customers? Well, we can do that using an operation called flatten, which Laravel's collection supports out of the box. And flatten takes a parameter, I'll just do it in line here, which is the depth to which we want to flatten it, right? So you could flatten it just like this, which is going to flatten every nested array it finds all the way down. In our case, we only want to flatten it one level. So we can say flatten 1, and now if we refresh the browser, we get 35 items. Oh. Come on, close. 35 items, and they're all customers. So this is now a collection of every customer that belongs to every employee in the Louisville district. So let's just chain this flatten call onto the end of all customers here. Flatten 1. And just dump the customers again to make sure we haven't made any mistakes. We still get that array of 35, so pretty good. Now this combination of operations where you map something into a bunch of subgroups and then you need to flatten it one level is such a common operation that most languages that support this style of programming have a built-in operation for it called flatmap, which Laravel's collection also supports as well. So instead of having to go map, then flatten it by 1, we can actually just call flatmap to begin with. And now that's going to give us the same result that we had before. So we still have that array, or sorry, that collection of 35 customers. So how can we kind of take advantage of the fact that we have this list of customers now? Well, instead of having to loop over all the Louisville employees, get their district, we already know this is not needed anymore, right? Because we filtered those out. And then get the customers for that employee and loop over those. We can actually just delete this outer loop completely. Missing one closing brace here. Pull this stuff over. And instead of looping over customers, we can loop over all customers. And if we didn't make any mistakes, we get the same value that we had before. Right, so we're still doing good here. We've done a little bit of refactoring, killed a couple levels of indentation, killed some loops, killed some conditionals. And now we got this loop where we're looping over all customers, figuring out what the total sales is for that particular customer by looping over all their orders and adding them together, and then checking to see if that customer's total sales is greater than kind of our threshold here, and if it is, including it in the total revenue. So what's the next thing that we can do here? So it looks like what we're trying to do is figure out for each customer what their total worth was in whatever the sales period is, right? Figuring out how much they paid us. So if we have a list of customers and we want to know how much each one of those customers paid us, and we want to do something with that list, It sounds like we want to do another transformation where we want to take a list of customers and transform that list of customers into a list of the amounts that those customers have paid us. So that's a map operation again. So let's create a new variable called something like customer totals, which is like going to be a list of the total values that all the customers have paid us, and figure out how we're going to like kind of get this. So if we take this all customers collection and map that, and it's going to take a customer, now we want to return the total amount of money that that customer paid us. Well, just to kind of move things along a little bit and do things in as small steps as possible, let's just rely on this code that we had before. So the customer total sales is 0. We're going to loop over all of their orders, figure out the total for that order, add it to the total sales for that customer, and then if we return that customer total sales. Now if we dump customer totals, we should see that we have a collection, same size as the collection of customers, that lists all the totals that each customer has paid us. But we haven't really made any improvements to like this code, right? We still have this nasty loop on the inside. So how can we get rid of this loop? Well, let's think about what we're trying to do and think if there's like a better way to express it. We're not trying to like sum or total all these up by like taking a counter and then looking at each one and writing down how much that is and adding it to what's there. Like if we're trying to express this in the simplest way, I think all we're trying to do is sum up the value of the orders, right? And Laravel's collection class actually provides us with a method called sum that allows us to calculate a sum based on a callback that we apply to each member of that collection. And that sounds like a lot, but I'll walk you through how it works. So rather than use this loop with this temporary variable and stuff, we can do something like this. Return customer orders. And now this is a collection itself. And we can call the sum method. And sum takes a callback that's going to return some value for each item, and it's going to sum those all up for us. So this callback is going to take the order, and now we have to return some bit of information about the order that I can use to perform the summing. In this case, it's the total of each order that we're trying to sum, right? So if we just return order total, we can delete all this code, run this again, and we get the same thing that we had before. And just to kind of prove that, let's comment this out. Actually, we've got some work to do down there still, so we won't do that yet. But this is kind of looking a little gross to me too, right? We got this kind of like nested closure stuff. We got this kind of triangle shape again, which I really like to try and avoid in my code. So is there any way that we can simplify this? And there is. So with Laravel's collection class, anytime that you're trying to do a sum like this on just a simple property, like if all we need to do is get one property off each item and sum it up, there's actually a shortcut for it. So rather than passing in a callback that lets us return the value that we want to sum up, we can just pass the name of the property that we want to sum up. So if we just pass total as a string, it's going to be smart enough to kind of get all that stuff for us and give us the same value. So let's kind of put this customer totals into better use here. So now we have a list of all our customer totals. So instead of this loop where we're looping over all of our customers and then figuring out the total sales for those customers, we've kind of done this work now. The only thing that's really left for us to figure out is our total revenue based on this thing, right? So if we do something like this, we'll delete this code, loop over customer totals. We'll just call this customer total. And now we can say if that particular customer total is greater than or equal to the minimum sales threshold included in the revenue. So if we refresh this, we get an error, undefined variable, customer total sales, customer total. And we get that 1.9 million again. So now we've managed to extract like a lot of this code into these kind of small, discrete, kind of independent steps, right? And the only loop and conditional we're left with now is looping over all the customer totals and deciding to add them up only if they're greater than that threshold. So what more is there left to do here? What can we extract? Well, let's try and get rid of this conditional. So how can we remove the need to check if a customer total is greater than or equal to our threshold? Well, if we knew that all the totals that we had were above the threshold, we could just add them together without having to check, right? So that sounds like another opportunity to use filter. So let's try and come up with a name for this variable. So customer totals, we'll call this like best customer totals or something. And this is going to be equal to customer totals filter, which is going to take a customer total, and we want to return whether or not this customer total exceeds the threshold. So we can say return customer total is greater than or equal to min sales. And this line is going to get a little long because we've got to use this nasty use statement. Turn off wrapping there. So now that we have best customer totals, to figure out the total revenue, we can just loop over our best customer totals as customer total. And this code should actually give us the same result that it did before, even without removing that conditional. Undefined variable min sales. Where's it? What line was that on? 57? Oh. Thanks. That's why I hate temporary variables. So we get the same value that we had before. And now if we go ahead and remove this conditional, because we know that all of our customer totals are already above that threshold, we get the same value. So the only loop that we have left in our code now is the one that determines the total revenue. Well, we talked about the sum function earlier, right? That sums up things based on a callback that you pass in. All we're trying to do here is sum up the totals of each one of these best customer totals. So we could just do something like this. Total revenue equals best customer totals. You know, we could do sum and pass in a closure that takes that total, or the customer total. And all it does is return the customer total, right? Because it's already a value that we already have. So this should give us the same answer, and it does. But in this case, since all we want to do is like sum up the items that are already in the array, and we don't need to perform any sort of transformation or fetch any individual property or anything, we can actually run sum with no parameters. And that gives us the same thing. Now, I would probably at this point look for other things that we can simplify, right? So we were able to eliminate that total revenue temporary variable in the sense that we got rid of it where we initialized it to 0 and we were kind of incrementing over time. We're just kind of assigning it to a variable now so you can pass it to number format, so I'm not really too worried about that. Min sales, I think I'd be happy to just inline that, or you can reference a constant, you know, if you're trying to be a good programmer. Or maybe it's a parameter, but we can get rid of this use statement now and run this again, and we're still good. And at this point, we have no loops, no conditionals, and no temporary variables, except the one that we're just assigning here to return at the end, which is really just for, you know, the purpose of keeping this code separate from the code that we're actually interested in talking about. We could inline that if we wanted. But anyways, we talked about inlining temporary variables before, right? We have all these temporary variables that we're building up. But if we were to look at like best customer totals now, this is the only place we're using it, right? We can inline best customer totals by just copying this code and pasting it in here. And now this line goes away. Customer totals only gets used here, so we can inline that by cutting this code, pasting it there. All customers is just this line here and only gets used once. So we can cut that and stick it here. Louisville employees, we can inline that the same way. Delete this line here, and if we run this code, we still get the same value. So here's like a solution, a solution to the same problem that looks like completely different than the solution that we had up here. And the reason we were able to land on it is because we're taking advantage of kind of these discrete independent transformations, right? So I find this code to be a lot easier to understand and a lot easier to maintain once you get comfortable with what these transformations do, for kind of one main reason. And that reason is that you never have to keep the whole thing in your head anymore. So if you look at this function, we have like a temporary variable getting set up here that we're incrementing down here using a value that's here, that was built up here, that was set here. You can't just like look at one small part of this code and understand what that piece is doing independently. You have to like figure out the whole function and keep it all in your head at the same time. Down here, we were able to kind of extract little small things that we could do totally independently and apply them in kind of a sequence so that I only ever have to really understand what each piece is doing. So we're taking the employees and we're filtering out the Louisville employees. Okay, so now I know that we have just employees from Louisville. Okay, we're flat mapping those to get those customers. Okay, so now we have a list of customers. We're mapping those into the total value of all of their orders. So now we have a list of order totals. And then we're filtering out any that are not past this threshold. And then we just sum them up. To me, this is a much easier piece of code to kind of reason about. So it's pretty cool that we were able to eliminate all the loops, all the conditionals, all the temporary variables, and I think it's kind of a fun style to program in. We're running a little bit later than I hope to be at this point, but I would still like to go through one small, quick example. So this is kind of a common scenario that you would see people use in collections when you have like some piece of data and you want to pipe it through a bunch of transformations and end up with some other data at the end, right? And in reality, a lot of the time, this sort of code is like better done in the database anyways. So I think it's really cool and useful to understand, and I still apply these ideas a lot. But in my day-to-day, I'm using collections in kind of a very different way a lot of the time. I'm not working on like giant data sets and trying to do crazy things. I'm usually actually just working on small data sets and trying to make my code a little bit more expressive. So for example, yesterday, we had a pull request come into Valet from my buddy Chris back home. He was working on trying to use PHP 7.1, like the beta version of PHP 7.1 on his machine. And he noticed that Valet didn't support PHP 7.1 in the sense that Valet does some checks to see if you have a compatible version of PHP installed before it will actually try and do anything. So I merged this pull request, but when I was looking at kind of the code that he had to change to do it, it started to feel like we were doing a lot of like repetitive stuff that I was not really super happy about. And I wanted to go back in and refactor it so it would be easier for people to kind of add this sort of change in the future. So I have the Valet code base up here, and we're kind of refactor this live. So there was this function here that checked to see if we had an installed version of PHP, right? And before the pull request came in, it was just checking these 3 versions. So we just had this kind of long Boolean statement that was saying, well, if PHP 7 is installed, or PHP 5.6 is installed, or PHP 5.5 is installed, then we say we do have an installed version of PHP. But if we just keep having to add a line to this every single time, like that's pretty lame. I don't want to have to do that. So I thought, well, what is a way that I could kind of solve this problem? And immediately, the thing that came to my mind was to do it using collections. And we're not trying to transform data here or anything, so I'll show you like what I mean and why I would use collections here. I look at all these and I think, well, this is just kind of a list of supported versions, right? So if we create a variable, something like supported versions equals, we'll make it a collection to start with. So Laravel has this collect global function that makes it easy to generate a collection on the fly by passing in an array. So this is going to take, this stuff. We'll just copy this in. So we have a list of supported versions, and we want to find out if any of them are installed. So one way that you might do this is using loops. You might do like for each supported versions as version, if this installed version return true. Otherwise, if none of them are installed, return false, right? And we have a test suite for Valet, and if I haven't made any mistakes, it's still green. So that still works. But we got a loop and we have a conditional, which is super lame and should be against the law. So how can we do this using collections? And again, this is just like a small data set, right? This isn't like we're trying to take some big thing that came back from the database and do something fancy with it. It's just a lot of the time when I see like people checking against multiple values, it's easier to treat it as like a list and do some sort of list operation to figure out whatever you're trying to figure out. So what we're really trying to do here is we're trying to find out if this list contains a version of PHP that is installed on the system, right? So we could do that like this. Check this out. If we just return supported versions contains, and now, has anyone ever used like this inArray function in PHP? Where you specify like a list and you check to see if some value is in that list? Contains works like exactly like that in the sense that I can check to see like, does supported versions contain 7.1? This will return true. If I say, does it contain PHP 6? It'll return false. But you can also pass a closure, which is what makes this like such a cool and powerful function. So instead of passing just a value, we can say, does it contain something where this closure returns true? So we can pass it a closure. The closure takes the key as the first argument in Laravel 5.2 and under. In Laravel 5.3, these are actually switched, and I'm pretty sure we're using the version that's on Laravel 5.3 or 5.2, but we'll find out quickly if the tests fail. This is just a convention that I use for variables that don't get used. I kind of borrowed that from a couple other programming languages. People probably think I'm weird for doing that, but it's fine. So it takes the version as the second parameter, and then we just want to return this installed version. And if we run the tests, they're still green. So what this is saying, does this list of PHP versions contain a version where checking to see if it's installed returns true? And this is the sort of thing that I end up doing a lot in little bits of code day to day. That's not like your standard like array transformation, but it is like a way to remove loops and conditionals in your code and kind of use more expressive functions that kind of better describe what you're actually trying to do. So I think we're basically at time here. So there's a couple other things that I could have gone through, but I'm not going to. This is kind of an important thing, I think, like learning how to use collections and just like random bits of code in your projects that aren't like big data transformations. Just anywhere that you see like lists of values, there's always a way to kind of do that with arrays. Anytime you see loops, there's always a way to get rid of them, even if it's just looping over a small number of things, not like doing some big data transformation. So hopefully that's kind of like an insightful look into like little things that you can do with collections. It's a little bit different from kind of what we talked about as the more like idiomatic use case. And if this is something that you found interesting, I don't want to plug it too hard, but I did write like a whole book on this stuff and released like a whole video course. There's like a bit.ly link that's a little easier to get to. It's also at adamwathan.me/refactoring-2-collections. Since I went over a bunch of kind of the fundamentals that's in the book, it's probably about 25% of the content, so I'll give you 25% off the stuff. So you can use the Laracon 2016 coupon to get 25% off if it's something that you're interested in checking out. And I host a podcast called Full Stack Radio. If you haven't ever checked it out, you should check it out. I interview lots of cool people, and I've talked about topics like this on there in the past. So that's a good place to find me and check that out. I'm also on Twitter at AdamWathan, and I blog about object-oriented design and programming, testing and stuff at adamwathan.me. So hopefully you guys learned something, and thank you.